These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm. Or you can just use the link in the info box. Thank you. Well, we need a systematic method for two-dimensional motion. We already talked about the systematic method for one-dimensional motion. So I hope that when you were doing the two-dimensional problems this week, you were trying to use the frameworks that we talked about last time. So remember, the framework is to write down the 5 kinematics variables and use that as our framework. So remind me, what are the 5 kinematics variables?
Delta x, initial velocity, final velocity, acceleration.
Good. But now that we're working with 2 dimensions, we're going to be working always with both x and y components. So we need more subscripts. For example, this is no longer going to be v initial, it's going to be v initial x, and this will be v final x, and this will be a sub x. All of these are subscripts, right? So unfortunately now some of the variables will need 2 subscripts, so it's important not to get lazy, but to write all the subscripts that we need for each variable. Notice, as I mentioned to 1 or 2 of you last time, how do we, well actually let's just go on to the y variables for a second. So what would be the y variables with all their subscripts? Time does not get broken into components because it's a scalar, not a vector. But everything else gets broken into components because all the other concepts are vectors. Notice that the way we indicate the x and y components for the displacement is different from how we indicate the x and y components for velocity and acceleration. For displacement, we don't need any subscripts because we can just say this is the x component of the displacement and this is the y component of the displacement. If you wanted to say the overall displacement, you might use r in this chapter. So this is the x component of r, and this is the y component of r. In fact, you might say delta x is really r sub x. I'm sorry, I guess I should say delta r to correspond to displacement, and delta y is delta r sub y. You won't see these concepts used, but that explains what these are standing for. So the first thing we want to do for any two-dimensional problem is write down all 10 of the variables. Again, we don't want to be lazy. We want to start by writing all of these variables out. Now, one thing this means is that we're usually going to have to break things into components. For example, knowing the overall velocity is not very useful. If we're given the overall velocity, we have to start by breaking it into components, an x component and a y component. A very common student mistake, again, is to be lazy and just plug in the overall velocity for one of the components. Well, we can't do that. Same thing for acceleration. That has to be broken into components. And same thing for displacement. If necessary, that has to be broken into components too. Another big mistake students make is they forget that all the components have signs as well. So you always have to figure out whether the component is positive or negative. Remember, the best thing is to put a positive sign in front of everything that's positive, and that will remember you to think about the sign. And then you'll notice the things that are negative. We talked about last time, when you have more than one framework, you have to ask which variables are the same in the 2 frameworks and which are different. Well, there's really only one variable that will probably be the same in both our x and y frameworks. What's the one variable that's probably the same in both frameworks? Yeah, the time just represents the total time that the object is moving. Well, that time applies to both the x and the y component. So whatever number you write down here, you can usually pull that over here as well. You guys have your textbooks with you? Let's try a problem then.
You have to join the 6th section.
Oh, no.
Hopefully we'll get something.
How about page 23? Not page 23.
Wait, what page?
Let me think for a second. I wanted, oh, I'm in the wrong chapter. Let's try again. All right, how about page 37? This is an example, so you should try to cover up the explanation, and we'll just try to do the problem.
Wait, page 23, right? 37.
I'm sorry, page 37.
Okay.
So here we are on page 37. So let's try to use this systematic method to attack the example here on page 37 without looking at the explanation, obviously. Let's give that a shot. This would be a good time, if you have the handout on projectile motion, to take that out. And we want to try to use those steps, the systematic method that we've talked about for kinematics. All right, well, we can kind of work this through together. So I think the first step is to draw the object's path. So we can say here that maybe we're starting at this point. We're moving at 7.3 meters per second. They don't say what direction we're moving in, so we might as well say that we're moving in this direction, say. And a wind gust, so this would be our initial velocity. And a wind gust hits, and that gives us our acceleration, which is at 60 degrees to the original direction. So here we have this angle of 60 degrees. All right, and maybe the path here is not going to be 100% obvious, so maybe I'll just write down these vectors to start with. So our initial velocity here is 7.3 meters per second. And we have our acceleration of 0.82 meters per second squared. All right, let's see. So what was step 2 in this method? Is that to choose positive directions? I forget my method.
Axes and positive.
Axes and positive directions. Well, very often we're just going to choose to the right and up as our positive directions. Let's choose these directions. All right, and then I believe that step 3 is to break things into components. So that's the step that we have to be not lazy about and actually do. All right, well, to start with, this one is a little bit tricky. What is the initial x component and what's the initial y component?
Have to make a right angle. The initial x component.
What's the initial, I'm sorry, what's the initial x component of the velocity and what's the initial y component?
7.3 for x and 0 for y.
That's a good answer. That's right. Sometimes the simplest parts are the parts that give students difficulty. This only has an x component. It doesn't have any y component. So we would say the initial x component here is 7.3 meters per second. But we shouldn't be happy with this. We want to get into the habit of always putting in signs. Well, would this be positive or negative?
Positive.
We might as well decide we're moving in the positive direction. And then this velocity will be 0. So it's totally possible that some vectors might have only one component, and then the other component still needs a number. Well, a mathematician would give that the number of 0. So that'll come up a lot.